Okay, so first principles is the last thing we're going to look at today. This doesn't often come up in the exam because it's quite tricky, but it is a good thing to understand so that you understand where differentiation came from in the first place. So what happens is, let's say we've got the graph of y equals x squared. Okay? If we want to find the gradient at 2, it is the same as the gradient of the tangent at 2. So that the gradient of that line is the gradient at the point on a curve. So what happens is that we can actually find out by using the values around it what it's going to be. So if we find this value here, if we say that we want to know what's happening at 2, and we make h a distance, so it's the distance to here is h. That's not h, that's plus h, all right? And we shrink that distance. As we shrink it, we're going to be getting closer and closer to 2, which will give us the value. So if we want to find out what the gradient is at that point, 2, which we're going to call x from now on, then what we can do is we can use limits to find it. So that limit statement says the limit as h approaches 0, as h shrinks down, so we're absolutely on top of that x value, of f of x plus h minus the f of x value over h. So what is that? So that's this value minus this value. So that's the difference in the y's, and h is the difference in the x's. So that's the difference in the y's over the difference in the x's. What does that look like? You're right, it's a gradient. So this thing here is just the gradient. What is happening to this gradient as the limit gets, as h gets close to 0, so we're bang on top of that variable. So if we have a look at this function, x squared, right? Let's cheat to start off with. We know that y dash equals 2x. So at x equals 2, y dash will equal 4. We know that, all right? But once upon a time, they didn't know that, so they had to do it by first principles. Well, actually, they worked it out really quickly. But by first principles, by looking at the gradients, what we do here is f of this, so this is equal to the limit, because we haven't done this bit yet, so we've got to put this at the front of every row. F of x plus h, well, we've said that f of x is equal to x squared. That's the function. So we've been given a function of x squared. So this is x plus h squared. Take away x squared. That's what f of x is. All over h. All right. We want to simplify this fraction here. So we still haven't done this bit. We leave it in the beginning. Expanding this, we get x squared plus 2xh plus h squared minus x squared all over h. All right, we can cancel those two out. So now we've got the limit as h approaches 0 of 2x h plus h squared over h. We want to take out h now. So we've got the limit as h approaches 0 of h, 2x plus h over h. So those cancel. So when it looks like h is going to be 0, what does it look like the function is going to be? So as the limit goes towards 0, this is going to equal 2x. So that's our new derivative. Therefore, at 2, we know it's going to be 4. All right, so that's called first principles, and we can do it to any function at all. But it's easier to do it to polynomials than it is to anything else. So we need to have a little bit of practice. I don't want you to do too many of them, maybe 3 or 4, just to have a feel for it. And that's today's lesson. Thanks, guys.